Okay, looking at coordinate conversion. Again, since this pole coordinate is kind of new to us, we can look at our pole, say it's somewhere along this line, where we've got this angle called theta, and we would call this r theta. Now, this distance right here, oh, didn't want that, is called r. And we can kind of visualize it, and again, this is where I got theta, as this is kind of like our, oh, too far there. Right here is like our x coordinate, and then this right here would be like our y coordinate. So again, when we look at our r and theta, you can kind of think about it as x and y. And so as long as r is greater than 0, then we know that some of our definitions are going to hold true. Tangent of theta equals y over x. Cosine theta equals x over r. And sine theta equals y over r. So we can kind of know that that tends to be true as well. And you can show that these same relationships hold for r less than 0. It just can't equal 0. And so this is kind of what we were just talking about. So let's do some examples. If we want to go from polar to rectangular conversion, so let's say polar to rectangular conversion. First point we're going to do is 2 and pi. So again, relating it to r and theta, I have 2 pi. So if I'm looking at what I wrote or what I have written down right here, x equals r cosine theta. And so in this case, it's going to equal 2 cosine pi. And cosine of pi, if I think about my unit circle, pi is over here, which means cosine of pi is -1. So 2 times -1 equals -2. And when I look at y, again, my formula tells me to do r sine of theta. So r sine theta, which in this case is going to be 2 sine pi. And pi is 0, or sine is 0 at pi, according to our unit circle. So this, not 2, Mr. Larson, this is going to equal 0. So the rectangular coordinates are x, y, and in this case, they are -2 and 0. Another example, polar to rectangular. If I have the square root of 3 and pi over 6. So again, I'm going to use my r cosine theta for my x value. And so r in this case is cosine, or square root of 3 cosine of pi over 6. And cosine of pi over 6 is the square root of 3 over 2. So this is really like being over 1. Square root of 3 times the square root of 3 cancels out, so I'm left with just 3 over 2. For y, it's r sine theta. So square root 3 sine pi over 6. Square root of 3, the sine of pi over 6 is actually 1/2. So I'm going to be left with the square root of 3 over 2. So my rectangular xy coordinates are going to be 3 over 2 and square root 3 over 2. Gonna try rectangular to polar now. Rectangular to polar. And so first pair we're gonna do is -1 to 1. So I know that, again, using this, okay, tangent of theta equals y over x. So again, this is x and this is y. So tangent theta equals 1 over -1, 1 over x, which equals -1. And so when is this true for our equation? We have theta is equal to 3 pi over 4, 3/4 pi. That's roughly where our equation would be. And so when this is true on our circle, again, when we have r theta, this position right here, if we had our polar coordinates, because theta lies in the same quadrant as xy, use positive r. So again, where am I getting this? I'm getting it right here. So r squared equals x squared plus y squared. So r squared equals -1 plus 1 squared. So r squared equals 1 plus 1. R, if I take the square root, r equals the square root of 2. One set of polar coordinates for this formula is, again, how did I get this? I got the square root of 2 and 3 pi over 4. Got one answer right here, and I got my other answer right here. We'll do another example just like that. Converting from the coordinates of 0, 2. So again, I'm going to choose, since it's on the positive side, again, if I look, where is x is 0, y is 2, that's going to be up here at pi over 2. Here's 1, here's 2. So I know that theta equals pi over 2. And again, r is pretty easy in this case because it's on a whole number, so we know that r is going to equal 2. Therefore, our coordinates are going to be 2 pi over 2. So in a sense, what you want to do is you want to work backwards. You want to figure out, what do you know? If you have the rectangular coordinates, then you want to use some type of conversion method. Are you looking for x? Are you looking for y? Are you looking for theta? Or are you looking for r? I kind of like, again, a shortcut, I guess, to looking at this one is you could say r equals the square root of x squared plus y squared. Because we don't usually care about r squared. We just care about r. So that can save you a step.